Deep beneath the Greenland ice sheet, there are clues to the climate of the past. Clues that can provide us with knowledge about the Earth's climate during the Eemian period, 125,000 years ago. A time when the Earth was 5 degrees warmer than today. And knowledge that can help us in the future as we face global warming. In the middle of the Greenland ice sheet, a group of ice core researchers are on their way across the ice cap. It is summer 2007. The tracked vehicles are pulling loads with tons of freight and struggle through the snow at just 4 to 5 kilometers an hour. The course is towards the northwest, where they will start an ice core drilling through the kilometers thick ice sheet. In all, there are 9 members of the expedition, which is led by Jørgen Petter Steffensen from the Niels Institute at the University of Copenhagen.
The purpose is that we want to investigate the previous interglacial period, the so-called Eemian, which was 125 to 130,000 years ago. This period, we know this period was 5 degrees warmer than today, and by finding out how that period evolved, we can compare that with our present-day climate and then get information on what's in store for us in a possible global warming future.
They have picked up drilling equipment and vehicles at a previous drilling site, North Grip, where they left all of the equipment 3 years earlier. During the short summer season, they need to transport all of the equipment to the new drilling site and get it established. During the first day of travel, they travel 27 kilometers and the caravan stops in the icy wilderness to set up camp for the night. The sun is shining, but it is minus 20 degrees. An oil pan of a motor makes a nice grill for steaks. And people learn to cope with the available solutions. The red huts are called the tomatoes, and it is here they eat dinner. The next day, they make a small ice core drilling. With a 2.5 meter drill, they make a so-called shallow drilling, which goes down about 70 meters. The ice sheet on Greenland is a unique archive of the climate of the past. The ice is formed from snow, which remains year after year and is eventually compressed into ice. Trapped in the ice's frozen grip are tiny bubbles of atmosphere, and each annual layer can tell about the climate the year the snow fell. By drilling an ice core through the ice sheet, scientists can determine the climate back in time.
Well, the shallow cores themselves reach about 200 to 250 years back in time, and that is, in our perspective, a very important time because it covers the whole period of industrialism. And that means that the bottom ice of those shallow cores is clear and pristine and basically unpolluted. And then we can see the increasing pollution going on in the industrial period.
The ice cores are measured very carefully, numbered and sawed in lengths of 55 centimeters, which can easily be transported.
A 70-meter fern core, shallow core, will provide us with 250 years of precipitation data obtained in one afternoon. As you compare to meteorological stations all over the world, they have to collect rainwater every time it rains for 250 years. We can do it in one afternoon because we have all what's been snowing there for 250 years in one single ice core. And precipitation data or snowfall data is one of the most important climatological parameters you can get.
Researchers from the Niels Institute at the University of Copenhagen have led several drillings through the 3 kilometers thick ice sheet on Greenland. The ice core drillings have revealed the Earth's climate back through our current warm period through to the long ice age, 125,000 years back in time. But the researchers would like to go even further back. They want to go all the way back to the last warm period, called the Eemian period, because the climate at that time was 5 degrees warmer than it is now. So knowledge of that time can improve predictions of what to expect in the future with global warming. But how do the researchers find the right place on the ice sheet, which has ice preserved from the Eemian period? The new drilling site must be carefully selected. And that happens on the living room floor at home with Professor of Ice Physics, Dr. Dale Jensen.
This big map here is a vertical cut through the Greenland ice sheet along the main ice ridge, going right from the south of the ice sheet to the north of the ice sheet. And it actually covers a region of 2,000 kilometers. We have 3 kilometers of ice between the surface and the bedrock. And when we look at the ice at the surface, it's the snow that fell yesterday here on the ice sheet. And when we get down to the bedrock, we have ice that's 125,000 years ago. So we have information of all the ice for the last 125,000 years.
Dr. Dale Jensen traces closely the distinct layers with already known ages.
When you look at the layers here, we can see that the oldest layer we can trace are about 80,000 years old. So we don't directly have layers that from the time period we're actually looking for, the Eemian, 130,000 to 115,000 years before present. So we can follow the oldest layers of 80,000 years and then look for places where we have a lot of space left below the 80,000 years. That would be the good places to drill an ice core to get even older ice.
By analyzing the layers, she finds the new drilling site, which gets the name NEEM. At this site, there is a lot of ice under the known layer, and here they are hoping to find ice that is up to 150,000 years old, meaning that they can determine the climate throughout the last warm period, the Eemian, where it was 5 degrees warmer than now. Now the expedition is on its way towards the new drilling site. They continue the 365-kilometer long journey with a northwest course towards the goal, the NEEM drilling site. Here, they need to find the position, which Dr. Dale Jensen has calculated from her studies of the radar measurements through the ice.
When we come to the new place, we have to determine whether this place is the exact right place or not. We might be 5 kilometers off one way or another. So we sent Lars off with the GPS, and it turned out we only had to move the train a kilometer or so to say, well, this is the ice ridge, and that's when we determined this is the right place to go for NEEM.
The mission is successful. They can now pack everything up and make ready for departure. The first field season has ended. The following year, in spring 2008, the researchers are starting a new field season. The camp must be built. A little vanguard group of 5 people are flown out onto the ice in a Hercules. As soon as the plane touches down, the tailgate is opened and the freight is ejected. It saves time, so the plane can quickly be on its way. They are left here in the minus 30 degrees cold and with a camp that is buried in snow.
We have 5 people with each our backpack, and we have a shovel each. This shovel is going to be the most important instrument in the next 24 hours because we have to dig, we have to excavate, we have to dig and yet again excavate things, and we have to dig out the cargo that contains our tent so we can get shelter overnight. So the first 24 hours is basically digging with a shovel each for survival.
The tent is dug out, more are set up, and the camp takes form. The vehicles are made ready in the biting cold at minus 21 degrees. They make a runway for the next plane. This is done with a tracked vehicle, a so-called piston bully, which levels and compacts the snow in order to create a hard, flat surface, so the 70-ton planes can land safely on the runway. The Hercules planes land on skis, so the runway must be 4 kilometers long. A new team arrives at the camp. During the next 10 days, 6 flights arrive with construction materials, tools, fuel, food supplies, and everything explodes into activity. Under the leadership of the American building contractor, the camp members set about building a large dome-shaped wooden building called the Dome.
Remember, finger tight on those.
The supports are made of steel, while the walls are built out of triangular wooden panels.
Well, we chose the dome construction because it is this spherical shape provides a lot of space inside for a minimal consumption of material. And also the dome shape is extremely strong, so it can withstand winds. It has a very good wind characteristics, so there are a lot of advantages having a dome-shaped building such a place.
They also have to have a large garage built, which is important because it is the only sheltered place to repair all types of machinery. Another big project is to use large snowblowers to dig out where there will be an underground drilling hall and laboratories for scientific studies of the ice cores. The weather is bad, with strong winds and lots of drifting snow. The doors can only be opened very carefully, otherwise the wind will rip the doors right off the hinges. The temperature is minus 27 degrees, but with a wind speed of 12 meters per second, the wind chill is down to minus 50 degrees.
So many blizzards with drifting snow that just backfilled these excavations at the same speed that we could excavate them with. So it was so frustrating. Everything was almost at a standstill. We were delayed in things. And then all of a sudden we had a few good days. We got down and we got a nice trench made, almost finished, when we got the forecast that within the next 24 hours we got hit by another blizzard. And that's where we decided, okay, we have to drop everything else in camp and just concentrate on one thing, getting this trench covered with a roof within the next 24 hours.
Finally, the weather is behaving itself. It is a race with time to finish everything during the short summer season, when you can be out on the ice sheet. Now they have managed to lay beams over the deep hole for the underground drilling hall, and they get a roof put on. The snow is solid, so it functions as solid walls. But everything is delayed. The camp is not completed, and according to the plan, there is a replacement crew. The new field leader is Dr. Dale Jensen.
Well, when I arrived, everything is far behind schedule. The big main dome is not finished. That was planned to be finished. And the trench digged out for the science trench is not roofed, so it's a big hole standing in the snow. And if we get a snowstorm, it would fill in with snow, you know, in one day, and 14 days of work would be gone. So my first impression when I came to camp was, my God, we'll be busy the next weeks.
The first priority was to get the dome finished for the 20 new residents. So there's a place for construction work during the day and a kitchen and living room in the evening. While construction and digging continues, 3 men depart for the old camp, North Grip, where there is some equipment they could not take with them the year before. At North Grip, they left the bulldozer, which is used to load the planes, and even though it has stood in minus 60 degrees for 3 winters, it starts without a problem and is driven out of the garage. There were also some old snowmobiles, some barrels of fuel, and some equipment, which there wasn't room for in the first trek from North Grip. After a journey of 730 kilometers, they are back at the NEEM camp 10 days later. The construction of the dome has made good progress. The building is 12 meters in diameter. It will have 4 floors and will include a kitchen, dining and living room, workplaces, toilets, showers and sinks, and at the top, a control room for plane landings. In the drilling hall, they set the little drill up 2.5 meters. It will drill around 100 meters down until the snow is compressed into ice.
Well, we are celebrating that we finally have reached the stage where we're able to drill the first ice core. And of course, that's what the whole project is about, drilling the deep ice. So we are celebrating the first ice core here.
Despite the big delays, they finished building the dome and constructing the entire camp and the underground halls. And they drill an ice core down to a depth of 92 meters.
And it's been a very, very active and busy season. But we have achieved all goals. We've built the camp and we've drilled 3 ice cores and made the first measurements. So the project is actually rolling.
The field season is over. The camp is shut down for the winter and everyone flies home. But is this the place which can tell us about the Earth's last warm period and help to predict the climate of the future that the coming ice core drillings will show?